Hey everybody, and welcome back to Front-End Expert. In this video, we will be discussing the various units in CSS and how to choose which ones to use. To get started, let's look at the various units that we can use for lengths. These can be used for properties such as width, height, font size, margin, and a bunch more. The most basic of these units is pixels, which uses the px unit. The most important point here is that pixels are an absolute length, meaning that they don't scale as the items around them scale, or if the user style sheet has larger sizes on it. There are a variety of other absolute units, such as inches and centimeters, however, these don't tend to get used much, so we won't be focusing on them in this video. On the other hand, relative units make our lengths relative to something else, and there is a variety of useful units here to choose what that something else is. For the EM unit, it will be relative to the font size. Moreover, if you're using an EM to set a font size, it will be relative to the parent's font size. REM is very similar to EM, except it is relative to the root element, which is the HTML tag. By default, this is usually 16 pixels, but we can always change that by changing the font size on the HTML tag. Moreover, this is oftentimes overridden by browser font size settings. VW and VH stand for viewport height and viewport width. So as the name suggests, they are relative to the size of the viewport. For example, 1 VW is equal to 1% of the width of the viewport, 50 VW is 50% of the width of the viewport, and so on and so forth. The CH unit is relative to the width of the 0 character in the current font, which essentially allows us to make widths based on the number of characters in a paragraph. Finally, percentages represent a percentage value relative to something else, usually the parent's value for that same property. However, do be aware that sometimes this can act differently depending on what property you are using. So that's great, but how do we choose which units to use? There are no hard set rules, but we can go over some general guidelines to keep in mind when choosing units. And of course, if you're coming into a project that is already in progress, being consistent with the existing code is oftentimes your best bet. First, let's look at widths and heights. For these, we oftentimes want to use the percentage unit, so the values are relative to the size of the parent. For example, it is common to want an element to take half of the width of the parent. Additionally, we can also use the VW for widths and the VH for heights, occasionally when we need a size that is relative to the entire viewport. This can be helpful for creating websites with a single page full screen style effect. The CH unit is very useful for a specific use case, and that is choosing the width of a paragraph. Once paragraphs go over about 70 characters in a line, they become really hard to read. So setting a CH value around 50 to 70 can be a good way to get a good readable paragraph. Finally, if you need an absolute value, I would usually recommend using REM. This is still a relative value, keep that in mind, but it is the closest relative unit to being absolute. What I mean by this is that for most users, it will display relative to 16 pixels, and it's not relative to anything else on the page. However, for users who have chosen to change their default font sizes, this will still scale properly. And as a last resort, if you absolutely need the width or the height to never change, pixels can be used sparingly. However, do keep in mind that this can be detrimental to accessibility, so we'll want to be careful using these. Next, let's look at margin and padding. For these, I tend to prefer using REM units for the same reason as widths and heights. They feel consistent and absolute, but will still scale with user preferences. However, sometimes the EM unit can be useful here as well. For example, if you have two sizes of the same element, you could use the EM to make sure that the margin and padding scales up with the larger font size. Finally, pixels can be used here, but again, I would be careful with this due to accessibility. As a general rule, pixels are fine for very small values, such as a 10 pixel padding, but as the values increase, you'll usually want to prefer REM, or of course you could just use REM for all of these values and almost never use pixel values at all. That said, moving on to borders and shadows, pixel values are usually fine here because we oftentimes don't actually want these to scale. Sometimes if a shadow is defined with REM or EM, it will become too big for some users, and this just won't look great. But that said, REM and EM are also perfectly okay here if that's the effect you're after. It's really just a choice of what exactly you want your borders and shadows to look like when a user has a larger font size. And lastly, for font sizes, I prefer using REM. These scale with user preferences while still being easy to work with. EM can be good if you want your values to scale with the parent size, but I tend to find these confusing in larger projects as the calculations for font size get kind of hard to follow if there's a large chain of parents. Pixels can be a last resort here, but in general, I would avoid them as they will oftentimes end up preventing your fonts from scaling with those user preferences. And like we've said already, we don't want to be preventing user preferences from working. Now, finally, let's take a look at colors. With colors, there are a few ways to represent them, but they are all essentially the same thing, so I would mostly just choose the syntax that you're most comfortable with. First, we can use the names of the colors, and this is for super common colors like white, black, red, or blue. However, for full projects, I would usually avoid these absolute colors, especially the ones like red and blue, because they can look pretty generic, and they also tend to be a little bit jarring to the eye. Next, we can represent colors using hexadecimal codes. The first two characters represent the amount in red, the second two represent the amount of green, and the third two represent the amount of blue. Next, RGB works the exact same way, except with comma-separated values in standard base 10 instead of hexadecimal. Additionally, there is an option here to include a last alpha value from 0 to 1, which essentially is the opacity of the color. Finally, HSL stands for hue, saturation, and lightness, with saturation and lightness being represented as percentages. This can also take an alpha value at the end, just like the RGB values can. It's also worth noting that for both the HSL and the RGB functions, it doesn't actually matter if you include the A at the end of the function, you can always include the alpha value regardless. These two functions are actually just aliases for the same thing with different names. Now, as for the right format, it's really up to you. Hexadecimal tends to be the most common, but personally, I find hexadecimal hard to interpret. It's hard to understand the meaning of it. However, the RGB values or the HSL values can be a little bit easier for a human to just read the name of the color and understand what it might look like. But again, it's up to personal preference, and the one thing I would say is make sure you're being consistent, at least within one project. So you don't want to have one CSS file with multiple styles of color because that can be a little bit confusing to read. And with that, let's move over to the code and do a quick demo of the differences between these units that we have seen. So here we have a div with the ID of parent, and it is the black border in the output on the right. And inside of that parent are three more divs, red, blue, and green, which are represented by the red, blue, and green boxes that you can see on the screen, and we'll see how exactly those are styled in a moment. And then below that, we have a long paragraph that says, I am a very long paragraph a bunch of times. So with that, let's move over to the CSS and take a look at how this is all working. So first, let's look at the widths. The parent has a width of 75%. So this is taking up 75% of its parent, which is the body. So 75% of the body, which is nearly the entire page. And then red takes a width of 50%. And 50% in this case is 50% of red's parent, which is parent. So red is 50% of 75% if we wanted to get red's entire percentage of the body it's taking up. But if we look at the output, that's why red is taking up half of its container. And then we can go to blue, and it's using a width of 50 VW, or 50 viewport width, meaning it is half of the size of the browser window. Finally, we have green, and it is using 10 REM as its width, which is essentially like using an absolute width in this case because we haven't changed the HTML element. So the width of this will be 16 times 10, which is 160 pixels. Assuming that the user hasn't changed anything with their preferences in the browser for the default font sizes. But now, what would happen if we changed the width of the parent? Let's make this, say, 50%. And we can save, and you can see now the blue one is actually overflowing because 50 VW is larger than the space the blue one had to fill of this parent. The red one, on the other hand, is still filling up half of the space of the parent because it is scaling down with the size of the parent. And the green one now is taking up about half of the width of the parent, but it hasn't changed. It's taking up the exact amount of space it was before, just like the blue one is taking up the exact amount of space it was before. And then if we scale this down even more, say making the parent 15%, now red is still fitting inside. It's taking up half of the parent still. But now both blue and green are overflowing, and this shows why, in general, I would recommend using percentages for widths. That way that your widths don't start overflowing and they will scale down with the size of the parent and always fit inside of it. Next, let's look at this paragraph. It's super long and it's kind of hard to read because of how long it is, but if I was using an even bigger browser window, it would be even harder to read. And this is a pretty bad user experience. So what we should do is we should change the way that that paragraph is scaling. So let's do paragraph and let's adjust its width. And usually what I recommend here is the CH unit. So we can say 60 CH, and that'll make it just a little bit easier to read. Now what's nice here is the width is entirely based on the font size and the font family. Essentially, we are saying we want a width of exactly 60 characters, regardless of the actual size that renders. So if I were to expand my browser window, you'll see the new lines don't change at all. This helps keep our paragraphs super easy to read, regardless of what size screen somebody is using to view them. However, if I came back and changed the width to 50%, then we no longer get these nice properties. Eventually, if I had a big enough monitor, then the entire paragraph would still end up on one line, which runs into the same readability problem we had initially. Moreover, it will even get hard to read if the page gets super small, trying to fit it all in a tiny window, when in that case we might prefer to just have a scroll bar. So in general, I would recommend using the CH unit for this. So let's go back to 60 CH, save that, and let's resize this a little bit again. Next, let's take a look at the font sizes. So right now, we haven't set any font sizes, so it's all just defaulting to 16 pixels because that's what the root element is set to. But what we can do is inside of red, let's set a font size of 1 EM. And then inside of blue, we'll set a font size of 1 REM. And finally, inside of green, let's set a font size of 16 pixels. We can save this, and you'll see nothing changes. And the reason nothing changes is, well, green is 16 pixels, which was the default. Blue is 1 REM, which is looking at the root element, which we haven't changed, so that's still 16 pixels. Red is looking at its parent, which is this parent div, which also hasn't been changed, so this is defaulting to its parent, which is the body, and eventually defaulting all the way back up to the root element, which is 16 pixels. But if we change the font size to the parent, say to 1.5 EM, and we save this, you'll see red gets a little bit bigger. And the reason for that is that red is EM, so it is relative to the parent. So this is also essentially now 1.5 EM because it's 1 times 1.5 EM, which will be 24 pixels because the root element is currently 16 pixels. Let's also go ahead and make this a little bit bigger again as well. Let's go back to 50% so we can see things a little bit easier. And now let's go and actually change the root element. So let's say HTML, and we can set this one to have a font size of, say, 24 pixels. So the default, again, is 16 pixels. So essentially now we're just making all of these scaling or relative font sizes 50% bigger. So now what's happened is the parent font size is 1.5 EM, which is 1.5 times its parent, and its parent is the body, and then its parent is the HTML. So it's going to be 1.5 times this 24 pixels. So this is going to be 36 pixels. And then the red is a font size of 1 EM, so it is the same as its parent. So it's also 36 pixels. Blue has a font size of 1 REM, and REM is going to just go to the HTML font size. So 1 REM is 1 root size, so it is 24 pixels for the blue font. And then the green font is still set as an absolute font in pixels, so it is still at 16 pixels. This is why we don't recommend using pixels for font sizes most of the time, because it won't scale if the user has changed the value of the root element in their browser. Now lastly, let's take a look at colors. So I'm going to change the background color of this blue one away from the standard blue, and instead let's add a hex value. So we can create a hex value starting with the pound sign, and then we add in the actual hex code 4B7DAF, and then the semicolon, and you can see that's a slightly lighter blue. And this is oftentimes the most common way that people display colors in CSS, But personally, I just find it hard to read. I see 4B7DAF, and I don't know what that means. But what we can do is instead have the same value, but as an RGB value. And personally, I think this is a lot easier to understand. So this RGB value would be 75, comma 125, comma 175. So that's going to be 75 red, 125 green, and 175 blue. And these are values from 0 to 255. Once we save, you'll see nothing actually changes, and that's because the value is the same, but I think this is a bit easier to read. We can easily see this and say, okay, this is mostly a blue and greenish color with maybe a little bit of red in there. We can also add an alpha value here, so we can add one more value to the end, and this will be from 0 to 1. So for example, we can say 0.5, save that, and now it becomes a little bit transparent. And if we change this back to 1, it would look the same as if we had no alpha value. And if we make it 0, it will be completely invisible. So I'll go back to 0.5 here and save it again. And now lastly, let's take a look at the same color, but using an HSL value. So HSL is hue, saturation, and light. So the hue value to get the same color is going to be 210. The saturation is going to be 40%. So we'll do this as a percentage. And then the lightness will be 49%. Do that as a percentage as well. And we can leave the alpha value alone. And you'll see nothing changes with the output. It looks the exact same. So again, with these colors, it's up to you which style you prefer, but just make sure you are being consistent. You don't want to be going back and forth in one file between different styles of colors. And with that, that's going to be the end of this video. I hope you enjoyed it. I hope you learned something new, and I'll see you in the next one.